Molarity. Molarity is the concentration unit that chemists use the most. And this relates moles of solute to liters of solution. Remember that mole is a counting unit. It's Avogadro's number of particles. And this is useful to chemists because when we're doing reactions or looking at chemical formulas, the ratios are all in terms of particles, not in terms of masses. And so molarity gives us a concentration that allows us to think in terms of moles. So molarity, here's the equation, moles of solute per liter of solution. And it's abbreviated with a capital M. So this is a very important equation to know. Molarity works really well as a unit factor. So if we see something like this, 2.50 capital M, that means molarity, the units of molarity are moles per liter. When we read this, we would say 2.50 molar sodium hydroxide. When you take this and write it, do not write capital M because you'll forget what it means. Capital M is more convenient when you're typing or writing something on a label of a stock solution. When you're doing calculations, you want to see all the units, not the abbreviated units. So 2.50 molar, when I handwrite that capital M, see this, is that a capital M or a lowercase m? Whichever you say, it's going to be wrong. You say, oh, that's a capital M. No, it isn't. It's a lowercase m. If you say it's a lowercase m, I'll say, no, it isn't. It's a capital M. The size, it's all relative, right? We use a lot of m's as units in chemistry. There's meters, right? And there's moles. And here we have a capital M, and then capital M is also mega, and lowercase m is milli. And so there's all these m's all over the place. And we need to be very clear when we're writing units so that someone doesn't misunderstand and think that it was 2.50 meters of sodium hydroxide. Well, that's a little crazy, right? It's like saying, I'll take 2 pieces of milk. What? How can you have a piece of milk? Doesn't make any sense. So what I do, a lot of people do this, is I underline the M. That way I don't have to make it very pointy and take a lot of time writing the capital M. I just scribble out a capital M and I underline it. And that says to people, this is molarity. So 2.50 molar sodium hydroxide, that's what that would look like in handwriting. This is the same as 2.50 moles sodium hydroxide per liter. This is the way that I would like you to write it down. Don't write the capital M. Write moles per liter, because then you can immediately see, oh, this is a potential unit factor. This relates moles of sodium hydroxide to liters of solution. I didn't write solution there, but you can certainly write that in, for liters of solution. So this is asking us to write unit factors, relating moles of sodium hydroxide to liters and milliliters of solution. Well, there's one, moles of sodium hydroxide to liters of solution. I could take that and turn it upside down and say 1 liter of solution per 2.50 moles of sodium hydroxide. How would I express that in liters? Milliliters. How many milliliters are in a liter? 1,000. Okay, so what if I did this? 2.50 moles of sodium hydroxide per liter of solution, right? It's the same thing. But what if I say 1,000 milliliters? Is that the same? A liter is 1,000 milliliters, right? So this is actually the same. Instead of liter, I'm writing 1,000 milliliters. And so this is a unit factor relating moles to milliliters. We could also turn that one upside down. 1,000 milliliters of solution per 2.50 moles of sodium hydroxide. Any questions? So solving molarity problems. This is similar to solving the percent problems. The first kind of problem might be calculating the molarity. To do this, we need the amount of solute in moles and the volume in liters. Those units are important. A lot of times they'll give you the solute in grams. How do you go from grams to moles? Use the periodic table, right? And find the molar mass. How many moles per gram? We convert grams into moles. If they give you the volume in milliliters or ounces or picoliters or something, you need to convert to liters. Then you plug those two numbers in here and you get your molarity. Another kind of problem is finding the mass of solute or the volume of solution. So we're going to use molarity as a unit factor. We just looked at that. You might need the molar mass of the solute. If they're asking for mass, the molarity gives you moles, and so you'll have to convert that. And you may need a unit factor relating milliliters and liters. I showed you how you can stick milliliters in there. If you're not comfortable with that, you can do it in liters and then convert to milliliters if you need to. Do a couple of examples. Calculate the molarity of a solution containing 1.50 grams potassium chloride in 250 milliliters of solution. So this is calculate the molarity. We're going to use the equation. We need moles of solute per liter of solution. So molarity equals moles, in this case it's moles of KCl, per liter of solution. Did they hand us either of those? No. They gave us grams of solute and milliliters of solution. So we're going to have to do some converting here. We need to take this 1.5 grams and convert to moles. Okay, and that should be pretty straightforward for you by now. This is an essential chemistry skill, grams and mole conversions. So I want grams of KCl in the bottom and moles of KCl on the top. The relationship between grams and moles comes from the formula and the periodic table. So potassium 39.10, and I'm going to add the mass of chlorine 35.45, 74.55. That tells me 1 mole of KCl weighs 74.55 grams. So then I take 1.5 divided by 74.55. And that's 0.020, That's the last significant figure. I'm going to toss in 2 more. And that's moles of KCl. So that's what goes in the numerator here. 0.020121 moles. And then they gave me the volume in milliliters. Well, they do that because most of the stuff we do in chemistry is on a smaller scale, and liters are a little bit too large to be measuring the volumes that we use in the lab. So we need to convert this to liters. 250 milliliters. Okay, this is something we learned to do at the beginning of the semester. We want liters. We want to divide by milliliters so the units cancel out. It's all about the units. And then we ask ourselves, what does the prefix milli stand for? 10 to the what? 10 to the minus 3. So I have the abbreviation for it down here. I'm going to write what it means on the other side of the line. 10 to the minus 3. And we can throw a 1 times in there to make it easier to put into your calculator. So you're going to have 250 times 1 EE minus 3, and you're going to end up with 0.2500 liters. This number has 4 significant figures. This is going to have 4 significant figures. Because this is a metric conversion, and you do not gain or lose significant figures when you do that. So that's the number that goes in the denominator, 0.2500 liters. So I can do that division, and I come up with 0.080483. Now, how many significant figures should there be? 3. We have to look at where these numbers came from. We started here with 3 significant figures. We divided by a number that had 4, and so here we have 3 significant figures. Those leading zeros don't count as significant figures. That's why I underlined this 1 to remind myself there's 3 sig figs. So that's up here. This one has 4, but 3 is smaller than 4, so we need to round to 3 significant figures, and so I'm going to call this 0.0805 moles per liter, or 0.0805 capital M. Any questions? So that's calculating the molarity. What volume of 6 molar hydrochloric acid contains 10 grams of HCl solute? .00 molar. That's moles per liter. Write it down. 6.00 moles per liter. And then I have 10 grams of HCl. This is moles of HCl per liter because it's the hydrochloric acid solution. So I've got 10.0 grams of HCl. This number in parentheses here is just to make the problem a little easier. You could calculate that, but we're just saying here, we'll give it to you so you don't have to worry about that. But these are the 2 numbers that are actually in the problem. And sometimes it's hard to decide which one am I supposed to start with. You start with the simple one, the one with the simple units. This is just grams. This is moles per liter. This is almost certainly a unit factor. This is what we start with. So we're starting with grams of HCl, and what are we trying to find? Volume. Now, it doesn't say what unit of volume, so what unit of volume would be the most convenient? Liters. So we're going to go and we're going to solve for liters of solution. Now, do we have anything that relates them directly? We've got this guy over here, moles and liters, and we were given this guy grams and moles. We could put them together, right? So we need to have 2 steps for this one. First, grams to moles of HCl, and then to liters of solution. So we have to think about it and decide how we're going to proceed. Write the path down so that if you get distracted in the middle of it or confused, you can go look at what you wrote down. Oh, that's what I was doing. Happens to me all the time. You're walking to the laundry room and then you can't remember why you went there. That happens in solving problems too. So 2 arrows, 2 factors. Grams to moles to liters. Grams to moles to liters. Put moles down here. Want those to cancel. We got grams down here. Want those to cancel. All the units first. This guy over here relates moles and liters, so 6 moles per liter of solution. That's going to show up here at the end. 6.00 moles per 1 liter of solution. This molar mass, 36.46 grams. And then moles is on the other side of the line. 36.46 grams per mole. Now we just go across left to right. 10 divided by 36.46 divided by 6 equals. And this should have 3 significant figures. 0.0457. What unit is left standing? Liters. And that's our answer. Any questions? When you have a grasp of unit analysis, these problems are just variations on a theme. No big deal. If you're still struggling with that whole idea of unit analysis, it's not too late to figure it out. But if it hasn't clicked for you yet, you might need some help. I would be happy, thrilled to help you figure that out. You want to do this one, or are you feeling okay with it? Yeah, we need a break. I need a break.